Math, 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 math. So we have a general strategy for integration, step-by-step sort of order of operations. So when confronting a tricky integral, what do you do? First of all, number one, try to simplify the integrand. So for this example, we will use trig identities. So pause and copy if you haven't done so already. Beep, boop, 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 boop. So my instinct is to switch the cotangent to cosine and sine, and then go that way, but probably a bit faster if you use this identity. Now I have a fraction in the bottom there, so I will multiply top and bottom by sine squared. So I went times sine squared on top and times sine squared on the bottom. And what appeared on the bottom is my familiar sine squared plus cos squared, which is just 1. That's just 1 there. Now I have some more trickiness appearing here. I got to bring out the 2. And then remember this identity, which allows me to replace sine x cos x with blah, blah, blah divided by 2. Okay, I'm getting closer here. I got the sine squared. I can sort that out using this memorized formula with theta is actually 2x in this case. And then finally, I have this very manageable doodad here, where I can just do a substitution, u is equal to 4x, and it'll work out no problem. Okay, so that's what I do to sort this out. So pause and copy, and we'll move on. So first thing you should be doing for an integral is seeing if you can't simplify the integrand. So pause, copy, and try this exercise. It's another trig identity thingamabob. Okay, next one. The next thing you would try is substitution. Okay, so if you can't simplify or simplifying doesn't help, try substitution. That's my next thing. So try to find an inside function. This one's tricky. I actually have to factor out the x squared. You see the x squared can be, the denominator can be factored. And when I factor it out, I can see, just based on being very sharp with derivatives, I can see that this choice of u is going to work because it's going to cancel this stuff in red quite nicely. So I perform my differentiation, and here I can see why the substitution is going to work. Solve for dx as usual. And the rest of this is pretty straightforward, so I will not belabor the point. Okay, if you choose the right substitution, then that can often be a pretty quick integral. You'll notice I don't have absolute values here because I notice that, well, this guy is never negative.